Swayam Prabha. Digital India. Educated India.
Welcome to the lecture on elements of mathematical modeling in Tundish Steelmaking. So far we talked about the prerequisites, especially we needed to know the concept of fluid flow, heat transfer. Then in the last week we also talked about the solution methodology of the equations and the solution parameters, control parameters, especially towards the solving of the equations. Now we will talk about the aspects of modeling, or when we go for mathematical or numerical modeling of the Tundish steel making. So as we know that when we talk about the models, then we deal with either the physical model or the mathematical or numerical model. Now in those cases, in the case of physical model, you need to prepare a physical model which is normally made of perspex sheet or so, and then we do the physical modeling by allowing the water, normally the fluid, to flow. Whereas in mathematical modeling, we have the set of equations which are representing the case of the phenomena which is occurring inside the Tundish, and then these equations are needed to be solved. And we also have studied that how the equations are solved and how you get the results. Now the thing is that being the era of computers, we normally do the computation on computers, and also for having a better understanding, visually we have nowadays tools where you can have the geometry creation, you can see the geometry, then you have to apply the conditions. So you have to take first of all these conditions, or you have to have the assumptions, and you have to also take all the conditions which will say that you are solving which type of problem. Then you are making the geometry and then putting the conditions, different conditions at different places, and then you are solving the equations in that particular domain, and then you are getting the results and interpreting them. So if you talk about the elements of the model, mathematical or numerical model, which you develop towards the flow in a Tundish, flow and heat transfer in a Tundish. So basically they are done under the three heads. One is the pre-processing, another is solving, and then you have post-processing. So mostly the CFD tools, when we use the CFD, do the CFD analysis. So basically our work is divided into these three main domains. So pre-processing, solving, and post-processing. Now what we do in pre-processing, in the pre-processing we do the geometry creation. So normally what we do is we have to create a particular kind of geometry, so that geometry will be available to you. If suppose you are making the model of the Tundish, so you have to make a Tundish using a tool which so by which you can create the geometry, and that we will discuss that how you create the geometry. There are many approaches by which you create the geometry. So, that geometry has to be there with you. In normal case, if you start the simple analysis, you can have a geometry of a rectangular shape of box if it is of 3 dimensional, or you can have a 2 dimensional geometry also. So, that geometry needs to be clear in your mind. Then what you do is you specify the material properties, material of the Tundish by which it is made, or material which is going to flow inside the Tundish. So, you will have the boundary material of the walls, or the material of the steel which is flowing inside. Then you are going to impose the boundary conditions. So, boundary conditions will be there, those conditions which are specified on the boundaries. So, boundaries are especially the walls or the inlet or the outlet. You may have blocks inside. So, and you will have boundary conditions maybe of different type. You may have the boundary condition related to flow, it may be related to heat transfer, it may be related to pressure. So, there may be different kind of boundary conditions which you need to specify in the domain, and then you are going to have the solution control parameters. So, once you put these boundary conditions, you specify different zones as the walls, or the symmetry, or the periodic boundary conditions or so, or you specify the inlet and outlet and all other things. Then after that you have to go for the solution control parameters. You have to provide those parameters which will be talking about the solution which will be done. So, basically there you need to provide the number of iterations you want to go further. Then you have to specify the time step size if you are going for the the transient type of analysis. So, you will go for the time step size that will be provided. Then you will also go for the parameters which will be helping you in getting the solution converged quickly and give you the meaningful kind of result. So, that will be the relaxation parameters. So, those parameters will be under that solution control parameters. Now, you have to go for the solving, and solving most of the tools may have a separate solver. So, that will ensure that the equations which are there integrated because of the type of problem you have taken and because of the conditions which you have given. So, ultimately they will be resulting into the set of equations, and these equations typically if you are solving, you will have Navier-Stokes equations, you have the equation for energy, and they need to be solved, and then they need to be solved using the solver. So, you may have the solving option also, and you will be solving these. So, that will run, and in case of the steady state type of the problem, you will wait till the steady state is reached, and then you have also many a times problems like in case of transient, you will see that the how with step size the iteration go forward, and then when the you are at a stage where the solution is solving process is over, then you go for the post processing operation. So, in the case of post processing operation, you are going to have the analysis of the results. So, you have you have the visual display of the results, you want to have the velocity or the pressure or the or computation of any parameter that we try to find, and that is known as post processing. So, post processing means after the solution is over, after the solver has done its job, then you try to further see the results, and since we have very effective tools nowadays, we can have the images, we can have the graphs being plotted for one variable and against another variable or so. So, you can have those different kind of graphs being plotted, and then you can interpret the results. So, that is also a very good part, very important part, because whatever you get the results, they need to be interpreted in a proper manner, so that you get the meaningful results. So, that is why post processing also is important, and there are tools available which will properly show quickly. It can show you the graphs of or a relationship between the different operating parameters, and then accordingly you can have these interpretation of the results. So, now we will go towards the geometry creation, which is the initial step, the first step, because first of all you need to have a proper geometry of the the Tundish or any vessel which you are making. So, you have to decide you are going for the 2-dimensional geometry or 3-dimensional geometry, and in that case you will have in the case of depending upon the type of geometry, you will have to choose, because if you go for 2-dimensional geometry, which will be enough for the complete representation of the flow behavior or the behavior of the system, in that case you prefer to go for 2-dimensional geometries, because that will take less amount of computational time. Else you have to go for the 3-dimensional geometries, and then the geometry needs to be divided into small elements, and as we have studied that you need to apply these conservation equations. So, you will have the suitable equations, you will have the algebraic expressions basically you get out of out of these conservation equations when you apply the different kind of differentiation schemes or discretization schemes. So, basically you are converting the whole domain into small elements, and then you are so basically you will have divide the domain into different control volumes, and then you are going to start the work. Now, as far as the grids are concerned, if you have to know that what kind of analysis you are going to have on the on that particular geometry. So, whether depending upon the geometry, you have to see that whether you are going for the structured type of grids, or you have to go with the unstructured type of mesh. Now, structured type of mesh are there, where normally you can identify the adjacent cell with the help of the ij and k values. If you are going for the 3-dimensional analysis, in that case if you have to locate a particular cell that can have a unique ij and k value. So, that is normally the structured kind of grid, and if you have the grid where it is not possible to have that kind of grid structure. So, that they are known as the unstructured grid. So, in that case certainly it uses its own internal data structures, its own internal programs, and with the help of that it will be taking, you can go for a particular point, or on a plane can be located, a surface can be located, or a volume can be located, and accordingly the analysis can be done. So, you can have these structured or unstructured grid. Then you have the element types. So, the element type, you may have, you may go for 2D structure, or you may go for 3D structure. So, based on that, if you have the 2D type of grid, so you may have the element type maybe like you have triangular, or you may have the quadrilateral type of element. Whereas, if you go for the 3-dimensional Rabo structures, you have different kind of grid topology. So, that may vary from the tetrahedron to hexahedron to maybe prismatic type. So, you have different kind of, or always shaped. So, may have different types of elements which you may choose when you are making the grids. Then approach of making the geometry. Now, here you must know that you can make the geometry in a top down or bottom up approach. So, this is normally available with the commercial solvers. So, you have many kind of commercial CFD tools like Phoenix, Fluent is there, Star CD is there, or there are many CFX and all these. So, these are using in their own way, they are making the geometries, and you have solid modeling tools also, like you can use the solid modeling tools, SolidWorks, CATIA and all that. So, you can use these tools to make the geometry. Now, making the geometry is using the top down or the bottom up approach. So, bottom up approach means you are starting from the initial and then making the things and moving towards the final result by adding in the adding stepwise, addition of stepwise, like you are first of all making the points, then you are joining the points, that is by lines, then you are making the faces, then you are making using the faces you make the volumes, and then you integrate them, and then in that you may specify certain kind of zones, like you may have the blocked zone where you want that it should be blocked or so, or you can specify there itself other zones. So, that we will see like different zones like wall, inlet or so. So, that is bottom up approach. In many cases we go for the top down approach also, like many a times it becomes helpful if you have to make, suppose one geometry, suppose you have to make a geometry where the things are suppose this way, that is tapered. So, in that case you can make one geometry of this type, and then maybe that you can take this part being off. So, that is removing this part, taking away. So, that will lead to this result. So, you can start with a rectangular type of or a 3-dimensional structure, and then cut a certain portion and make the required geometry. So, that is bottom up top down approach. So, you make the larger geometry, and then you are reducing that and getting the required geometry. So, that is using the top down approach. So, both the approaches basically are in practice and used by the modeling tools to make a proper geometry. Then comes the meshing parameters. So, once you make the geometry, you will be making the geometry, you will be integrating them, you will be making a complete geometry of which will be physically representing the domain. Then you have to go for the meshing of these geometry. Now, why meshing is important, that we know that by meshing we are going to have the formation of the small control volumes or elements which will be linked to each other, so that when we apply these conservation equations and solved, when the equations are solved simultaneously, in that case you are going to have the values of the parameters or variables in the respective cells or at the respective nodes. So, the meshing needs to be done properly. Now, while meshing you need to have the proper care for the mesh size. So, you can have the large number of meshes. So, mesh size will be small, you can have a small number of mesh, so mesh size will be larger. Now, every as it is quite evident that when you take a large number of mesh, in that case the computational time will be higher, and when you take less number of mesh, the computational time will be lower, but then certainly the accuracy will be affected. So, accordingly you have to take the mesh size. You have also to be careful while taking the mesh size, what should we, by what way even the mesh size should vary. So, in case of the boundary layer regions, you may have to have the proper variation in the size of the meshes from the walls to the point in the active domain. So, that to basically properly predict the output parameters, you need to have an understanding of that also, that how you have to maintain those mesh size. Then the density, that is what it talks about, and also the aspect ratio. So, typically aspect ratio will talk about the ratio of the dimension of the mesh in the perpendicular directions. So, basically we try to have aspect ratio of 1 normally, which is more ideal, but it is not always possible. So, we try not to have a very large value of aspect ratio in most of the cases. So, these are the points which needs to be looked into while going for the meshing. So, once you do the meshing, then it will show, and you can have a look of the mesh, that how the meshing has been done. So, you have to go for the checking of also the meshes, and you can the softwares have the capability to ensure that there is proper mesh. Otherwise, they may tell that there is no proper meshing, there is no proper integration. Maybe once we the situation may be such that you have done the meshing, but the portions are not integrated. So, there will be two different zones, and there may not be transfer of information from one region to other. So, all these things need to be checked into while when we do the final meshing. At that time, you need to check all these things, so that you can go further, and when you go for specifying the other parameters in the domain. So, that time you have not to face much of the problem. So, after the meshing and after the geometry creation, we need to be looking at the specifying zones as well as the boundary conditions. So, what we do is that, as you know, in typical at Tundish, you have different parts, like this is a Tundish. So, if you will have inlet and then you may have the outlet. So, typically you have these these are the walls, and then this is suppose inlet and this is the outlet. So, that is there, and then you have these are walls. Maybe that many a times we use a certain kind of dams or weirs that are the flow modifiers. So, what is done, some of the tools, while making geometry itself, you can show them as you show them as the walls or the blockages, and some of them while providing the solution control parameters or while giving the boundary conditions, there you have those options where to define that this is wall or so, and then accordingly you have to provide the proper boundary conditions. If you look at the this, so what you have to do is, first of all you have to define the zone, where you define the boundary type and you also define the continuum. That is, so in boundary type normally you have the boundaries specified in terms of walls, because external boundary is normally the wall. So, you will have to define those surfaces as the wall. Similarly, you will have the conditions like the inflow. So, you will have inlet. So, that will be the inflow boundary condition will be there. Then you have outflow boundary condition, that will be outlet. So, basically while making geometry also you can specify those zones as the walls or the inlet or inflow or outflow or symmetry. So, it will go there, and while you are giving the proper boundary conditions, at that time you can have the selection from the drop menu, that if you take wall, whatever you have specified as walls they will come, and properly selecting them you can have the proper values fixed to them. So, accordingly this way you provide these you specify these zones as the boundary types, and then you are going for the continuum or the so in continuum means that you are going to define the domain wherever you have the fluid. So, you will say that it is going to be occupied by the fluid. Similarly, wherever you have the existence of porous materials, in case of porous flow. So, you have to define that this region needs to be specified as the porous material, and similarly if there are blocks or solid portions, so you need to define them. So, as I told that you can define these things either while making geometries, or you can and there itself, or while you are specifying the boundary conditions, you can do that job while going for the specifying the zones and the boundary conditions. So, once you have given those specified these zones as boundary types, and also the continuum, that is where there is fluid, where there is solid or so, or porous media, then you have to provide the solution control parameters. Now, solution control parameters means now after that you are going to have the solution started. Now, what you need for need to specify when you have to you want to talk about the solution to be started. So, basically you have to tell that whether your solution is steady or transient. So, if it is steady, it is fine. You have to tell that for how many iterations you are going to stop after how many iterations you are going to stop and see the result. Whereas, in the case of transient analysis, you will have the specification of the time step sizes. So, for in a particular time, depending on the step size, you will go, it will go for that many number of iterations, and you are going also to provide certain relaxation parameters. So, that parameters need to be specified towards getting a converged solution. So, these relaxation parameters will be provided, and then the solution will start, and it will reach till you get the results. So, once the solution is over, in that case, after that you go and do the post processing of results, you interpret the results in your own way. So, this basically these are the elements of a typical model, mathematical model or numerical model which you are making, especially with the help of you must be having the exposure to certain of the tools, modeling tools. So, you have to proceed and you have to have the information about these things, so that you can get the meaningful results after the post processing, after the processing operation, that is in case of post processing. So, we will talk somewhat more about the boundary conditions and all that, how it is, what are the different kinds of boundary conditions which are imparted and all that in our coming lecture. Thank you very much.